because when you want to talk about the parallelism, so I'll just first cover the SQL tuning advisors. I got into the AWS report. This is what AWS report, which will ideally look, and I was discussing about the advisory statistics. Go here and check the SGA tag advisory. This will ideally will tell you the value which we set is right or not. So right now, we have to check the number 1.00, which means my SGA size is 180 GB. If I increase the value to say 200 288 GB, there may be a less IO for this durations. So this is how you have to look into it. Go to SGA tag advisory. This is your current value, and you can look into the estimated physical rates from 9 something to 8 something. If you increase your SGA to 200 GB, this is how this will ideally help you to reduce the actual physical rates hit to the server, hits to the disk, and if you have enough memory, that will read the data from the disk to the memory, avoiding the IO issues. This is one classic example, and there are similarly you can focus on PGA target statistics, which will also tell you the PGA memory advisory is there. So 1 GB, one is the value which is the 20 GB I think PGA, and if already having enough memory, there is no recommended value. If you are seeing the values are reduced in this estimated time, and we can look into corresponding PGA memory advisory and set the value accordingly. This one example we will be covering in detail when we focus on the actual course. We will be covering in detail each of these topics. Right now, I'll just quickly move into. We were discussing about SQL tuning advisors. So go here, check the top activity. SQL tuning advisor will tell you what's the it will give the generic recommendation like based on your current SQL statistics. If there is any need to create indexes starting 12.2 or 11, I'm not sure. Some recommendation may be to set the table into parallelism. So these are the real-time statistics. If you want to check for any given queries, you can check the SQL tuning advisor. Check the select which I want to tune because that is quite high on the IO. Hope you're able to see the IO uses. The green colored, highlighted greens are with respect to CPU. Waiting for this to be loaded, and then the blue colored one is not there anymore. So we'll pull the things to some 10 minutes back to get the problematic SQL, and we'll be focusing on it. So this is the blue colored one is the IO issues. IO issues means what some queries that is really quite high on the IO, and there may be a candidate that can be tuned, or we should be in position to check whether that can be tuned or can't be tuned all or optimized correctly. So it will take some time to load it. We'll go on to next one. So when you wanted to tune the SQL tuning advisors, you can use, if you wanted to tune SQL, you can either use SQL tuning advisor, which will give the basic recommendation like indexes, having said indexes, parallelism, and whether optimizer stats are up to date. And there may be a case where you do not need to create indexes because if one table may be referred by many other applications, and if the table has some 10 plus columns, it's not possible for us to keep creating an indexes on all the 10 columns. So we should be in position to increase the SEA and set the table to some parallelism based on your CPU cores. You can increase the parallelism, and that will really help for certain SQL queries. And SQL hints. SQL hints is very interesting, where you do not need to recode or restructure the SQL. If you know where is the problem, you can rightly hint. There are thousands of hints available, and the very commonly used hints are maybe 20. Uh, we can, if we are sure that certain hints will really help, test it, and if it really helps, and you can really hint it with the problematic SQL for the performance benefit. And then optimizer is the one is, which gives the responses based on the optimizer the SQL responses. The entire SQL responses are based on the optimizer settings, starting from 8i, 9i, 10g, 11g, 12g, all are based on Oracle optimizer settings. So there are a number of optimizers, but really we need to focus on some 5 6 optimizers which we'll be discussing in the later slides in detail. Next is Oracle joins. So this is the most of theoretical class, and we'll be seeing the practical in the next course. We'll be going in detail of each of these bullet points: parallelism, SQL hints, what is optimizer, what can be done, and what we need to set it. Oracle joins. There are, hope you can familiar with some nested loop join, hash join, and short merge join. These are the very familiar joins which the DBS should be aware of it by looking into the explain plan and what can be done to tweak it. If there is any because sometimes optimizers may behave badly, so we are in position to correct it based on the by looking at the sequels, to try tweaking, try changing the different, try giving the different joins like nested loop. If you really want to change the hash join, you can really force the hash join, and if you wanted to force short merge join, you can still do it. So it all needs enough testing and proper analysis before we put into productions. And then compression. Compression plays really big if you have enough CPU resources, and if you're not worried about the if you're running in VM, and if you're not worried about the CPU resources, you can still go ahead with the compression options. There are different types of compressions: compressions for OLTP, compressions for data warehouses, where we'll be discussing in detail the next course. So each of these bullet points. And then table level parameters, small, big table size for caching. There are some certain parameters which can be set at the database level to cache the table based on their usage size. I'm not sure about the exact parameter, but we'll be discussing in the slides the actual when it comes to the detailed discussions. The setting this parameters will really help to keep the data within the memory, not to be aged out of it. So we'll discuss in detail. And there are some parameters which can be controlled with respect to the sessions, because the optimizers or other parameters set at the database level is applicable to all the throughout the DB, but still we can control the optimizers behavior at the session level. We'll see how it can be done. And performance issues, we can the basic things which DBS or other application developers can look for is logs. There may be some hung situations, or sessions may be hanging, and we just need to check the logs and clear the logs. That would really help. And check for the concurrency as well. If there are more load, you may see some concurrency issues with respect to hot blocks, and we can take it forward based on the table size or table settings, table structures like PCT increase, PCT free, and we'll see how on what can be done to fix those issues. And if you have standby databases, that is data guard, primary and standby, you can advise the application team to divert the read-only queries to standby. That would release some burden on the primary. So this is the case where the business wants to keep running the reports. They will be connecting to the actual production databases, and they start running the reports. So we have restricted those settings, those connections to the primary, and we advise the application team to configure it correctly so that those reports can go to the standby, uploading all the read-only queries to standby, and distribute the and then when it comes to rack is not meant for the really the performance benefit. It's kind of high availability. There are some hiccups, certain wait events which has to look when it comes to rack. Rack is nothing but to distribute the load, not to overload the server with huge. If you're tuned all the sequels, if the recommended memory parameters, OS parameters all set, if you still see the the CPU usage is really above 50 60, then that may be a candidate to go for additional server, which is nothing but migration to rack from standalone to rack. So based on the OS stats, you should be able to discuss it. And to continue with the SQL tuning, so when it comes to the performance issues, you should first make sure that when you got the sequels from the OEM monitoring or from the sessions wait event, you have to make sure the underlying table stats are up to date. because the plan may change, the execution plan may change if the stats are still, and we have to make sure that key segments stats are up to date for the application to perform better. Starting Oracle 10G, Oracle sets the Oracle has been automated to gather stats, but still we can take control and keep doing the stats on time, because there are some application teams who um, deletes the records or truncates the records, load the data, and then keep querying the table on top of it as part of their process. So we can't wait for the Oracle to gather stats, because that will be run on the scheduled time. We can recommend them to include the gather stats as part of their procedures right after the truncate and data load. Please gather stats before you keep querying the SQL queries on top of the problematic tables. So some application team, what they do is truncate,